Alrighty, guys. So today we are going to be talking about new discoveries on the moon, thanks to Chinese space probe that has just landed there. That's been there for a couple months, has gotten us samples and has returned them to Earth. For the Sky Report, we're going to be talking about this giant turkey that's going to be in the night sky this Thanksgiving. So tune in for that. And finally, we're going to be talking about the field of AI kind of overlapping with astronomy, as I'll be talking about how AI is being used in simulations to simulate solar storms. But anyways, all that and more will be coming. This is Interstellar Insights. Alrighty, guys. So I apologize there wasn't an episode last week. I was quite busy outside the podcast to the point that I just couldn't really fit it into my schedule for last week. And I'm also a little bit sick, mainly in the throat. So if I'm coughing, that's that. But anyways, before I actually start off with this topic, I just wanted to talk quickly about the, I believe it was space test number 6 for Starship, I believe, that happened last Monday. Yeah, it was pretty big. Really, besides the failure of the giant metal chopsticks, really, I think that failure for Tesla is fine, because that allows them to improve. So if it's successful, great, but failure, that's fine. That just means you got to go back to drawing board and look at it. That's kind of how I looked at the space test or spaceship test from last week. So very interesting stuff there. President-elect Trump was also there. So I don't know if that'll mean anything for SpaceX in terms of more tests, if they're going to be able to run more under a Trump administration, or potentially by the end of the decade, if we're going to send the first human to Mars. So there is a lot of speculation on that end. But anyways, let's actually get into the actual topic, which is basically a bunch of records in terms of observers on the moon. We have Chang'e 6, which let me get a little bit background. Chang'e 6 was it's still operational, is basically a lunar exploration spacecraft that was basically launched last May, and it touched down on the far side of the moon. So the face of the moon that we normally see in the night sky, but then there's the side that we don't usually see, the dark side of the moon that we do not see in the night sky. And basically, there have never really been any spacecraft that have landed on that portion of the moon. So this spacecraft was the first one, and basically it's this lander that collected samples and then launched them back up to Earth, back to China. And of course, the CSNA, or the China National Space Administration, has been put in charge. Of course, this is a mission done by China, like I said. But anyways, the main historical first of this mission is the fact that Chang'e 6 has managed to send approximately 4.27 pounds of rock and soil samples from the moon, which is a big deal. I can't really go off the top of my head, but I can tell you that 4.27 pounds of moon on Earth is a pretty big deal. So potentially the largest transfer of moon rock to Earth and for scientific purposes. So yeah, and then another interesting bit of it is that these samples actually reveal volcanism on the far side of the moon that really isn't present on the near side, the side we see in the night sky, because usually there's not that much basalt. It's very cratered. There's a lot of seas, the mare, the black spots, but that's not really present on the far side. It's more of a thicker crust with more basalt. In fact, most of the basalt on the moon is actually on that far side, and then of course besides that thicker crust, and then I believe there's more basins in terms of the geographic landscape of the moon. It's going to be more basiny of basiny. That's not a real word. It just has a lot more basins. I don't know. I've had a long ish day. Excuse me. But yeah, more basin. It's just got more basins. I mean, both sides still have craters, but there's not really any of the sea or mare features that we tend to see when we're looking on the near side of the moon. But another big old shocking finding was the heavy presence of creep basalt on the far side of the moon. I don't know why I'm having trouble speaking today. But basically, this creep basalt is a form of slightly radioactive basalt that contains a good chunk of potassium, rare earth elements, and then, of course, some phosphorus. Of course, potassium is radioactive. You just have to eat 10,000 bananas to really experience that, radioactivity. But nonetheless, potassium has the capability to be radioactive. But anyways, there's been a lot of theories and speculation over why, this area of the moon has a bunch of this creep basalt stuff. And the kind of prevalent theory regarding why there is this huge swath of it over the far side of the moon is that the far side of the moon was basically the site of where, in the early formations of the solar system where there were a bunch of protoplanets, and then, those protoplanets smashed together to form, the planets in the solar system. They believe that during the time that Earth and the moon formed, there was a protoplanet that slammed into the Earth, and part of that protoplanet came together to form into the moon, and then the moon proceeded to get, smashed with more protoplanets, not substance, I'm not trying to make it, more protoplanets, start colliding into it. And this giant, flat of creep basalt is basically kind of an indicator of, that there was once another protoplanet, and it got slammed into the moon. The moon obviously took its mass, so the moon got bigger, but the remains of that protoplanet became, this creep basalt flat. And I don't, if you guys don't know too much about geology, if something is foreign, like take meteorites or something like that. Actually, a good example is with the dinosaur extinction. They found out that the dinosaur extinction was caused by a meteorite because they found a large crater, and then within that crater there was, I believe it was iridium, which I believe is a rare earth metal, but the amount of iridium was so much that they knew that it wasn't natural, and it was actually something from space. So something like that with the Chicxulub crater, and determining that was a meteor. That's kind of what they're doing here with the creep basalt, and the rest of the moon doesn't have this creep basalt. So the only logical explanation is that it's foreign, and it came from another protoplanet or meteor or another object that slammed into the moon millions and millions of years ago, and left it here. And then I guess I should note this. Like I said earlier, this is the first mission to the far side of the moon. Before, now, we really didn't have an understanding. I mean, we could predict some stuff, but we didn't have any conclusive evidence regarding that. So this is quite the talk in the field of astronomy, very big deal. And there is I believe Chang'e 6 is still functional. So we should be, getting more data back from the far side of the moon, and hopefully we can study this more, because similar to how we still haven't really explored the ocean. This is a part of the moon that astronomers still do not know very much in particular. In terms of geography, the geographic terrain of this area, as well as the geology behind it, such as with the creep basalt. So there is just a big treasure chest full of knowledge from this area of the moon that's just waiting to be uncovered. But anyways, that is all I've got regarding this new eye-opening discovery. I mean, we sometimes talk about. I think it's mainly if you, yeah, it's mainly like SpaceX, and I believe it was the Japanese rocket that fired a couple months ago by Japan Space Agency or something like that. I can't remember off the top of my head, but we mainly talk about rocket launches on our show. But this is kind of our first. I believe this is the first time on our show we've really talked about results from one of these missions. In this case, the Chang'e 6 lunar spacecraft. So yeah, that is all I've got for this topic. Let's go move on to I'm going to call it like a kind of a Thanksgiving special regarding the Sky Report. That there is something very, very spectacular happening this Thanksgiving that you guys should not miss. Anyways, let's go move over to that now. Alrighty, guys, welcome to the Thanksgiving week edition of the Sky Report. I guess I should rephrase it. The 2024 week of Thanksgiving and Black Friday and all the time to go out to get shopping because of these super good deals. But it's also a great time to go out in the night sky because there is something spectacular that will be here this Thanksgiving. But anyways, let's start off with Wednesday. And Wednesday, there's actually nothing in particular happening in the night sky. And all the action was mainly this morning with the moon being paired up with Spica, and basically they kind of, I wouldn't say orbited, but the moon was kind of like paired up with it, and then like the moon passed Spica around 7 p.m. about 0.4 degrees north of the star. So yeah, I mean, nothing really happened this morning, but tomorrow is a big day because the Orion Nebula is going to transform into a giant turkey. That is right. You have heard me correctly. There is going to be a giant turkey in the night sky. Now I know why you're thinking why. Well, obviously it's because of Thanksgiving, and obviously it is not due to the creation of memes that the astronomy community has created of the Orion Nebula looking like a turkey. So yeah, everyone go out after picking out a Thanksgiving dinner. Go see this giant turkey. After eating a big Thanksgiving meal, the last thing you need is just this giant turkey looming up in the sky, just staring off in the cosmos, and you just stare up at it. But anyways, the Great Turkey Nebula, as this new nebula shall be proclaimed on Thanksgiving. Like I said, this is the Orion Nebula, but it has manifested into a turkey in the spirit of Thanksgiving, if you know what I mean. It's basically going to be out for the whole evening, but it'll be pretty high up in the sky. It's going to be about 30 degrees high above the horizon, about 10:30 p.m. Oh, that reminds me. The turkey has just reminded me that all these times are in Eastern Standard, Eastern Daylight Time. So if you don't live on the East Coast, go figure it out. Like, I'm not your therapist. Go cry that you live in Mountain Time or Pacific Time or Central European Time or Hawaii Aleutian Time. Like, I don't care. Just they're all in Eastern Standard. So go deal with it. But anyways, Thursday, giant turkey. It's kind of an after treat after pigging out at Thanksgiving dinner. I myself have a plan to just not eat anything all day till like dinner time, and go ham at the dinner table. Well, not go ham. They're at the dinner table, but like in terms of food portions, if you will. But anyways, that following Friday, aka Black Friday, aka the day everyone goes out shopping, Jupiter is going to be in the night sky. It's going to be kind of blazing around in the night sky in terms of position, and it'll be sitting around the western bounds of the winter hexagon at about 10 p.m. local time. The winter hexagon is a winter asterism. I believe it's only the winter, obviously. It's because it's called the winter hexagon. But it's an asterism that connects 7 stars. And I was it connects 7 stars. But I know what you're thinking. How can there be 7 stars? A hexagon has like 6 points of where the straight lines connect to form the polygon. But actually, 2 of these stars are points in the formation, which leaves 6 stars to basically create the hexagon. But for this formation, we'll be starting at the bottom. So I'll be reading off the stars that are going to be here. Starting off at the bottom, we have Sirius. Of course, Sirius is the brightest star, and that's going to be at the bottom. And then if we move clockwise, we have Procyon, Castor, and Pollux. And then we're going to hit the top of the hexagon with Capella. And then we're going to be finishing the hexagon by looking at Taurus and Regal before arriving back at Sirius and forming the full hexagon. So anyways, that is the night sky giant turkey. Times for sunrise and sunset. For today, sunset's at 4:36 p.m. Moonrise is going to be at 3:30 a.m. Well, actually, that was this morning. Moonset is going to be at 2:28 p.m. Thanksgiving, the 28th, sunrise is going to be at 7 a.m. So go up, see the Thanksgiving sun before watching the Macy's Day Parade. Sunset's going to be at 4:36 p.m. Moonrise is going to be at 4:31 a.m. And moonset's going to be at 2:51 p.m. On Black Friday, the 29th, sunrise is going to be at 7:01 a.m. Great time to wake up to beat the line, I guess. Yeah, sure. Sunset's at 4:35 p.m. Moonrise is at 5:35 a.m. Moonset is going to be at 3:19 p.m. And the moon phase, that's going to be pretty prevalent throughout the week, is going to be waning crescent. Although, I think it would be cool if the November supermoon was on Thanksgiving, along with the giant turkey nebula. Just think about how cool that would be. But another trend, I guess if you will, excuse me, another trend is that sunset's going to be pretty early in the day for a little while. I mean, we're about to hit the winter solstice, and then of course our days are going to last slightly longer here, at least in the northern hemisphere, where I live in Maryland and stuff. So yeah, big deal. And then of course Thanksgiving, after you're done picking out, go take a look at this giant turkey, reminisce about it, or you could just look at the meme if you do not believe that the Orion Nebula will manifest into a great bird, if you will. But anyways, that's all I've got for this Thanksgiving special Sky Report. Let's go move on to our next big topic. Alrighty, guys. So, we're here. Last major topic we talked about was the Chinese spacecraft, the moon discovery. We're actually now going to change our focus to the sun, and how we are combining the fields of AI to kind of work with astronomy in terms of, studying the sun. So most of this work is being done at the University of Hawaii's Institute of Astronomy, or the IFA, and they are currently developing basically simulations that allow them to simulate solar storms. And most of their work right now published, in the Astrophysical Journal, which is, I suggest you guys go take a look at that. Very interesting journal filled with tons and tons of new groundbreaking studies in the field. But yeah, that's the Astrophysical Journal. But I mean, for the IFA's current work, they mainly focused, talking about the development of, AI, kind of deep learning, if you will, artificial intelligence, all that stuff. Mainly from data from the Daniel Kinzu Inouye Space Telescope in Maui, where they do all their, solar observations and stuff. But I'm sure we talked about this when we're talking about the solar storms, and we know that solar storms, obviously, they damage, electricity, or not electricity, they just take out the power, but they can damage satellites and electrical equipment, which, as you can see, is kind of a threat to the a telescope to be able to record data properly during such solar events. So of course the obvious fix to this is to make a solar simulation. So basically this simulation the best way to kind of put it, it's very elaborate. It's basically a mimic of what the a telescope would observe during a solar storm, and then of course part of that is being able to measure polarized light and the sun's magnetic field. But like the actual technology itself is quite advanced. Like developing this AI took like 10 million CPU hours on a supercomputer. I believe that's the Cheyenne supercomputer by the or not by the owned by the National Science Foundation. This thing does take a lot of storage regarding the actual development, but it's being used to further our understanding of solar storms, especially given kind of the limitations our current technology faces. So besides working on studying the sun, we're now also working on or actually I said it wrong, dang it. I meant to say discovering stuff on the moon. We're just going to pretend I never said that, the first bit. Working on discovering, we've already discovered the moon. Working on discovering the far side of the moon. We now are kind of complementing that with using neural networks and AI to analyze the sun. So that's basically it I have for this topic. Of course, they are still working on it, so we will see updates in the future. New discoveries might arise because of this new technology, and of course just the general advancement of this technology, and kind of the if you're into AI and astronomy, this is kind of like an example where those two fields of science collide, which I think is very cool. And we'll see AI being further integrated into the way we look at the universe. So yeah, that is all I've got for this very, very important topic. Let's go and do this week's edition of Astronomy Trivia. Alrighty guys, welcome to this week's edition of Astronomy Trivia. Before we get to this week's question, I would like to talk about the question from 2 weeks ago, since of course I wasn't able to get on air to do last week's episode, so there was no Astronomy Trivia obviously. So we'll just talk about the question 2 weeks ago, and I believe it was asking what kind of stars are going to last the longest, I believe, or what star type is going to last the longest in the universe before dying out. And so the answer to that question is actually going to be red dwarfs, mainly because red dwarfs, they are the smallest stars, so therefore they have a lot of fuel, but they're not going to have to burn as much compared to a red supergiant, which is going to have to consume a lot of fuel, in order to balance the forces. Because like we've talked about, stars are just this giant balancing act of its own gravity and the force exerted outward in reaction to the gravitational force from like collapsing, and of course that turns into a black hole and neutron stars. Basically, neutron stars are when the gravitational force gets so strong that the only thing that can really support the stars is the neutrons. But yeah, for red dwarfs, they have the longest lifespan. They don't have a lot of mass, so they can be a little bit more efficient in terms of fuel consumption of from hydrogen to helium. But anyways, let's go move on to this week's edition of Astronomy Trivia. If you thought there was going to be a Thanksgiving-related question, unfortunately there's not, although maybe during the weeks leading up to Christmas, I might actually find questions related to Christmas. I think that's a great idea. I need to do that. Very, 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 very big brain thoughts by me. But anyways, the question for this week is, who discovered that the universe is expanding? Who discovered that the universe is expanding? I'm going to go make a poll for both our YouTube and Spotify listeners, and you guys can answer there. Anyways, let's go and close out this special episode. I guess this is really special. I mean, the only thing Thanksgiving related was the Sky Report, but other than that, it was kind of normal. I would call it the special edition of Interstellar Insights. We're just roll with it. All right. Let's actually go. Alrighty, guys. So next week, hopefully, I'm not too busy. Other than that, it's gonna be. Ooh, yeah, I'm still a little sick. Where was I again? Oh yeah. Next week should be regular song and dance, as long as I'm not too busy. So regular podcast episode next week. Kind of a long-term development. I'm thinking of so I'm already thinking of clipping shorts from the podcast and then making shorts with them. But I'm also thinking of getting Universe Sandbox for this Christmas, and maybe we could do some shorts using that software and do a bunch of what if scenarios, like what if Earth had 5 moons, or what if Jupiter was at the center of the source, and those kinds of things. So in the comments down below, I would like to hear your opinions, regarding of such shorts. They would be separate. I wouldn't really talk about it on the main show or the bonus show or whatever. They would just be kept to shorts. And then, of course, with that, I would be creating a corresponding Instagram account so people can see them there. But anyways, I will update you guys on developments regarding that. That's basically all I've got. Anyways, if you guys liked this, episode, smash the like button. If you want to support me, I suggest everyone go and subscribe. It means a lot to me dearly. Developing this podcast, one person subscribing really does go a long way for the show. So it is important that, we can get that and, improve the quality of the show, new segments, new fun things to make this show more interesting. Well, guys, I think that's all I've got. I hope you guys have a happy Thanksgiving. And this is Michael signing off.